Welcome back, day 2. We are learning nothing new today, just have a whole bunch of examples. And I say nothing new, but I still want you guys to watch this today because I'm introducing a little bit more difficult problems. So no new, brand new information, but just problems that you probably haven't seen before. So our essential question is going to stay the same. Can I solve equations with x in the radicand? And we're just going to jump right to right to examples. We have 4 of them today. And my hope is that by doing these ones with me, the assignment today, you're going to see very, very similar problems. And you're going to be right there and ready to go. Example 1. This one looks kind of tricky because all of a sudden there's division problem. And it's like, oh, I don't know what to do. But bear with me. I promise you that this one is not any more different than the ones we did before. I'm going to look at my previous day's notes, which had 3 steps. Get the root by itself, square both sides, and then solve. And I'm going to write like a very small, simplified version of this. Get the root by itself, square both sides. I'm going to use the same color here. Square both sides, then solve. So I'm just writing a simplified version on today's assignment so I can quickly look at it. In this case, get the square root on its side, but all by itself. Well, let's look at this side. Is it all by itself? Yes, it is. Check, check. We're done with that one. Second step, square both sides because that is going to undo that square root symbol. So it's going to get rid of it like that. And on this side, nothing is eliminated or nothing's undid, or I don't know what the prefix or undid. Okay, whatever. It's not undoing anything. 6 squared is 6 times 6, which is 36. Then we're going to solve. Can I get x by itself? How do I get x by itself? This is a one-step equation, not an e-problem. An equation from 6th grade. X is being divided by 3. You are going to multiply both sides by 3. Those eliminate. And x is equal to 36 times 3, which is 108. And we are all done. We followed those 3 steps, and we got to the end. Let's do another example. This one is going to not have a square root by itself first. We're going to have to do a little bit more work first. It was a longer problem. Okay. Ooh, that line. Oops, sorry. We need to get that radical by itself. So let's just pretend that's an x. Like our goal is to get all of this by itself. It's being multiplied by 2, and 3 is being added to it. So we need to get rid of a 2 and a 3, and we're going to get rid of the 3 first, because we always get rid of adding and subtracting first. So we're going to subtract 3. Okay, we're almost done. 2 is being multiplied by the square root of 3x. So I'm going to divide by 2. Square root of 3x is equal to 3. And my first step is done. I got the square root all by itself. My second step is to square both sides because that gets rid of or undoes the root. And then my last step is to solve like normal. So we're going to divide by 3. X is equal to 3. So sometimes the radical is not by itself and you need to do a little bit more work to do that first. Example 3. This one looks even more crazy, but I promise it's not. It's actually probably easier than the one we just did. Okay. First step, get the radical all by itself. Well, there's 2 radicals. Can we put both of them on one side? No, we just want one radical all by itself. So I'm going to choose this radical. It's all by itself. Even though there's a radical over there, it's fine. We are going to square both sides because that will eliminate that radical. So that's awesome. We like when radicals get eliminated. But because this was also squared, instead of squaring a number, we're squaring a radical. So that also crosses out. Then you solve like normal. This is a one-step equation. Get rid of x, and 1x is equal to 6. So you might see problems where there's not one radical, but there's two. And if you put them on either side, you can just square both sides and it will eliminate the square roots. So let's look at a fourth example. I'm going to run out of room, so I'm going to put it up here. Okay. 2x plus 1 minus the square root of x is equal to 0. In this case, we have two roots. So when I say get the square root by itself, you can pick either one. I'm going to pick this one because if I add the square root of x, it's going to stay positive on that side. So I'm going to add the square root of x to both sides to get that radical by itself. And if both radicals are by itself, it makes our life even easier. But in this case, I want to get the radical by itself because I did that. And once you get the radical by itself, you square, and that gets rid of the radical, or it undoes the radical. But over here, there was also a radical. So those also eliminate. And then you have an equation that you can solve like normal. There's a ton of different ways you could do this. You could subtract two x's. I always like to subtract the smaller amount of x's. And then I'm almost done. I need to get x by itself. And then you are done.